Welcome to the show. I'm Andy Smith with Jordan Skala Engineers, and I'm here today to enjoy a great conversation with Brian Taylor. Brian, tell me a little bit about what we're going to be talking about today, which is ERRC. What is it exactly?
So ERRC is a public safety system, and it stands for Emergency Radio Responder Communication Systems.
That's a long word to memorize.
It is a very long word, and the worst part about it is the system actually has a half a dozen different names that, depending on who you talk to in the industry, everyone has a different thing they're going to call it.
So I understand that, ERRC had been around for quite a while, but what happened after the tragedy of 9/11? It sounds like it really started to gain some real importance in our day-to-day building design.
So that's right. So during September 11th, obviously most people know that part of that tragedy was firemen, other first responders were in the buildings, and they weren't able to communicate with one another, both to personnel inside the building and to personnel on the ground. So when some of them were on the higher levels and the building started collapsing or the tower next to them started collapsing, they weren't aware of what was going on. As far as they knew, they were still in an emergency situation, but they didn't realize how dire the consequences ahead of them were because they weren't getting that information in real time. So after that tragedy, the industry realized, okay, we need to come up with a system that can get rid of this problem. We need to make sure that whatever the building is, whether it's a high-rise or even a 6-story building, firemen, police, people in that building, they need to be able to communicate with the base station on the ground, with all of the people who see what's happening outside, and make sure that everyone's safe,
Okay.
both from the people in the building and for the first responders that are actually trying to help everyone.
Okay, so those responders that are in the building, are they communicating
Right.
with somebody on the outside?
Typically, that's how it works. You're going to have, people at the fire truck outside or at some type of base station they've got set up. But the system's also to make sure that they can communicate within the building itself. In the case of the Twin Towers, it was a massive high-rise. You have somebody at the top floor, they may need to communicate with someone who's about mid-level in the building. They couldn't even do that properly. So
That's really interesting. Yeah. So, how did this evolve code-wise? I remember back as a young designer, it was in the code even, I think, what was it, 2009 International Fire Code? When did it first come out in the code, and how has it kind of evolved over time?
So they did start to implement it to the codes. I believe it was the 2009 International Fire Code, or it may have been the 2012 International Fire Code, where it really started to pick up steam.
Yeah, that's what I heard. The 2012 really changed the timeline of how aggressive a lot of authorities having jurisdiction is wanting to employ this design. So, for many, many years, it would be in the code, but we never really used it. What was going on with that?
So part of the problem was if you look at that time period around 2012, it had been a little over a decade since 9/11 had happened. Those systems were being developed and the standards around them were evolving. So by 2012, you kind of had a foundation for how they work, how they should work, had some regulations in place, but it was still a very new system to most of the country. So a lot of AHJs, what we found back in those days were they weren't even really familiar with what was required, what type of buildings needed it. Many of them had never had it on any buildings in their jurisdictions. So they didn't quite know how to enforce it yet. That hadn't really caught on until later years.
Yeah. I've always heard a little joke that people that design ERRC and people like yourself that are low voltage designers, we always call you really cool data dudes because it stands for the acronym, RCCD, I guess.
That's right.
And what exactly is that?
So that's actually a radio communications distribution designer certification. That is the sort of the gold standard certification for a low voltage designer.
Okay.
It's provided by Bixby.
Yeah. Well, really cool data is how I remember it.
I actually like that better.
Well, let's go to another question I've got, and I'm sure our audience would be really interested to understand because it's confusing to me too. I hear ERRC, DAS, Cellular. We have radio enhancement. There's acronyms and all kinds of crazy, ways that our clients, our developers, our architects, building engineers all reference ERRC. So what's all the differences between them and why is it so complicated?
So I think part of why it's so complicated is the International Fire Code calls it ERRC, the Emergency Responder Radio Coverage System. a lot of developers and people in the industry just use the umbrella term DAS, which means distributed antenna system. But then it gets even more confusing because DAS can stand for cellular DAS, which is a luxury system. It's not technically required in a building to enhance cell phone service. But an ERRC system is by nature a distributed antenna system. So you'll hear public safety distributed antenna system. Okay. Or a lot of code, like the NFPA, a lot of different code versions, they'll also refer to it as just like a public safety or a first responder or a two-way emergency radio system.
Okay. So DAS is not always required.
Correct. So the cellular DAS, the cellular DAS is not required really in any building. It's one of those systems that has gained some traction on and off over the years. It's very, very expensive. I mean, all of these systems can carry a hefty price tag, but the
everything's expensive today, it seems like.
Very true. Yeah. And the cellular system's almost prohibitively expensive. So you see stadiums use it, large hotel chains. People very concerned with making sure people have cellular service in their buildings.
Okay. Very good. So, there's a misconception. I mean, does code really require ERRC in every building? Walk us through the steps as a designer. Mm-hmm. This is your expertise. You work all over the United States for Jordan and Skala. Explain to us a little bit about, when you go to design a project, what's determining when and where you need to use these systems?
Yeah, so that is a common misconception. People think that the code says that ERRC systems are required. But technically what it says is all new buildings have to have a minimum signal strength throughout the facility. So by the letter of the code, you have to have a certain dB level measured in 95% of all areas of the building. And then there's an additional stipulation where 99% of the critical areas in the building, so places like stairwells, those also have to meet that minimum dB level for signal strength.
And if you don't meet it?
If you don't meet it, typically historically the AHJ would have a number of options that you could do to meet that signal strength requirement. We would see in older versions of the code, it had a lot more leeway as far as alternatives. You might see the two-way communication systems, firemen's phone jacks, things like that. But as these codes have evolved with subsequent versions, you see more and more AHJs pushing the full ERRC system. If you don't meet the code minimum signal strength, just go with the ERRC system because it's become a very reliable, much more robust system over the years.
Okay. Sounds like we're going to see this on a lot more projects going ahead.
Definitely. Okay. So, and it depends on the state. You go to some states, like I mentioned earlier, even though the code's evolved over the past decade plus, there's a lot of jurisdictions that still aren't familiar with it, especially more rural jurisdictions outside of major cities. But those jurisdictions within major cities like Atlanta, Miami, Orlando, New York, so on, they've become much more familiar with what the code requires, what makes sense to put into your facility, and they've started to enforce it a bit more heavily.
And do you see this mostly on high-rise or urban areas? Like you'd mentioned New York, but then you also mentioned Florida. Very different, markets, project types. Where do you normally see these, or does it not matter what project type it is?
So technically it doesn't matter. So the way the code's phrased is all new buildings. There used to be some kind of exceptions based on the size of a building, square footage, if it was under 2 stories. Later versions of the IFC that I've seen have actually taken that out, and they just have that all new buildings language. But with that said, a lot of factors go into it. So it depends what the building's made out of, wood frame versus concrete and steel. That's why you don't see it a lot on a garden style apartment. But because of that code requirement that all new buildings have to have a certain signal strength, technically even they have to be able to pass a test that the fire marshal would do on site. But to answer your original question, yes, if you're designing a high rise or even a large wrap style apartment building where maybe it's 6-7 stories, but you've got a lot of steel and concrete, large parking structure in the middle. In a lot of cases, they're almost guaranteed to need the system just because those materials prohibit you getting signal inside the building.
And I guess if you have a project today with nothing surrounding it, but over the coming years, development happens and you build high rises or mid rises around an existing project, I guess you may have to go back and revisit those buildings, or what's done in those cases?
So that's kind of a weird gray area right now. So there has been talk with some of the different councils who come up and update these codes about annual testing. And as far as I'm aware today, there is no stringent requirement as far as the overall code that there has to be annual testing. But it's something a lot of AHJs have been preparing for, and it's something that building developers need to be aware of. Like you said, maybe you have a 6-story building, you get lucky, it passes every test, you've got your minimum dB level throughout, you don't need the system. 2 years later, somebody builds a 30-story high-rise next door, and it might coincidentally be blocking the direction of the jurisdiction's radio antenna. Suddenly, your building that didn't need it needs it moving forward. So,
Okay. I guess economically it makes sense to put some infrastructure in early on just in case.
yes, 100%. That is
Okay.
really the smartest thing any developer can do because retrofitting is extremely expensive.
Okay. Well, I'm going to have to reference my notes for a second because I had to write down a few things to ask you. Related codes. We have NFPA, National Fire Protection Association 72, 1221, and the newer 1225. How do these NFPA codes play into what you do? Because we were just talking about just a minute ago. You were referencing the International Fire Code here,
Right.
and now you're talking about international, 2012 and international codes. So now you got National Fire Protection codes. What do you do? Are there conflicts between them? I mean, how do you apply all of these? How are they relevant?
So technically, there's no conflicts between them. Fortunately, they work out in a way where one code is not negating something in another code. But it can be confusing because depending on the jurisdiction, if you're referencing multiple codes, you're jumping from one place to another to try to figure out how this one system works. So the way it's kind of delineated is the IFC covers your basis of when and why the system's needed.
Okay.
It covers those minimum dB requirements, where the building needs coverage or doesn't need coverage. Then you've got NFPA 72, which is the fire alarm and signaling code. That code touches on a lot of safety systems like fire alarm, but there's a section in there, Chapter 24, that covers ERRC systems. Or, again, this is some of the confusion on the name. They refer to it as a two-way radio enhancement system.
Okay.
So they touch on some of the requirements as far as the survivability of the system, just some additional pieces that aren't explicitly stated in the IFC. But to further confuse the issue, depending on the version of the NFPA 72 you're looking at, it references another section, NFPA 1221. So NFPA 72 will say that your system's backbone cabling, all the riser cabling, has to meet a certain survivability requirement. They don't, or at least the current version doesn't publish what those survivability requirements are. It tells you go to the NFPA 1221 to see their list of survivability requirements at different levels.
While you're talking about this, I almost see like sparks, like voltage just coming out of your head. You seem so knowledgeable about the subject. So cool. Well, let's change gears for a second about the backbone. What is a backbone, and why is there always a conversation with architects about providing a certain rating protection for fire? Tell us a little bit about that.
So the backbone is technically just what's coming from the roof-mounted donor antenna. So that's, in most of these systems, they're considered a passive antenna system, meaning the jurisdiction is going to have a radio tower somewhere that's pumping out this signal. It's in the 700 to 800 megahertz range, pumps it out through the jurisdiction. You've got your antenna on the roof that pulls in the signal, and then it distributes it down to the bidirectional amplifier, and that's the head end, the brains of the system, the BDA. That cabling between them, and then if you have any remote units throughout the building, that additional cabling is what's considered the backbone. So cabling from the BDA to the antennas that you see in the corridors, the dome-shaped antennas.
Yeah, I've seen those, yeah.
Though that's not required to be rated or anything like that. That's just standard cabling. If it's in a plenum space, you would plenum rate it. Otherwise, it's just standard non-rated cabling. But that backbone, that has been a huge point of contention for years and years. Like you said, a lot of our clients have brought up things about 2-hour fire ratings.
Yeah, what happens if your building's only got 1 hour ratings?
So that is why we've seen so many changes in these codes, which codes apply, and a consolidation of some codes. So NFPA 72 years ago had some notes in there about a 2-hour survivability for this life safety backbone. More current versions of the code have kind of rolled that back, and it's in reference specifically to fire alarm systems. It's no longer a blanket reference to any emergency communication system. So now it references NFPA 1221. That more specifically calls out backbone for ERRC cabling. And some jurisdictions, this is a newer code. It was originally copyrighted in 2021, has officially been adopted in some places as of 22. Like the state of Georgia has adopted NFPA 1225. That lumps in 1221, everything that has to do with the ERRC system. And it also lumps in NFPA 1061 that has to do, it's a little less applicable to what we design because it's the qualifications for people who would run the system and commission it, things like that. But it puts these codes in one place so that it's a little less confusing to try to jump around. But it also made some common sense changes, like you're saying. So for years, an architect would, rightfully so, but we were just designing per code. They would question why we were calling out a 2-hour rating or 2-hour survivability on this cabling. Well, we did it because the code told us to. We'd hear, well, our building's 1 hour rated. And, a common kind of joke was, so the entire building's going to burn down and we just have this run of cable or this shaft that's just, going 60 feet in the air and that's the only thing left. So now what the code stipulates is if your building is fully sprinklered, it does not require any rating on the backbone cabling. If the building is partially sprinklered or non-sprinklered, then it typically runs into basing it on the building's fire rating. So if the building is 1 hour rated, your ERRC backbone's 1 hour rated. If the building's 2 hour or above rated, then the ERRC backbone has a maximum of 2 hours it has to be rated.
But the purpose is that lifeline. I mean, it's a critical infrastructure from point A to point B. You're making sure you're protecting it. You
need to make sure it's kept intact. And another thing to kind of roll off of that, and clients should definitely understand this, and we try to make sure that this, especially when we're brought into a design early, we make this very clear because the cost can vary widely depending on how you achieve that 2 hour survivability or even 1 hour. There are manufacturers out there that make a 2 hour rated cable, but it's very expensive. When we first started hearing about it, it was as much as nearly $100 a foot. Wow. It did come down to about $40 a foot, which is still very expensive. I'm not sure how current economic conditions have affected that. It may be going up in price, but either way, that's sort of your last ditch option. Maybe you forgot to put the system in or it was an afterthought. You have to rate the backbone. There's a good way to do it.
Okay. And you provide advisement to our developers, architects, as to economies of scale as to what options they have.
Right, and the best thing you can do is, since the backbone just has to have 2 hour survivability, you can achieve that by either A, running it in a room stack that's already rated. So you may have a stack of electrical and telecom rooms in a building that just, for their own code reasons are already 1 or 2 hour rated. The cabling can be freely run along the wall in those rooms. If you don't have that, you could always build out a very small, 1 or 2 hour rated shaft.
Okay. Well, let's switch gears and talk about states. We mentioned it already. You mentioned New York, you mentioned Florida. So, North Carolina is another one, I think. What should designers and owners keep in mind when it comes to the different states and their jurisdictions and how they interpret things? Because it seems like you almost have to do some due diligence up front, maybe?
That's true. So one thing you have to consider, Florida and North Carolina are prime examples. Those are states that have their own fire codes that are essentially pulling in pieces of the IFC and maybe some snippets from NFPA codes, but they've got their own requirements. The state of Florida, they tend to be one of the more stringent enforcers of the ERRC systems. They're one where if your building's not meeting that minimum signal strength, you're almost guaranteed that that's going to be the only solution, is that you're going to be told to put an ERRC system in.
And something I never really thought about is, do we typically seal and sign low voltage drawings like we do an MEP set of drawings?
No, so low voltage drawings are not typically required to be signed and sealed. There are some exceptions. Sometimes Washington, D.C. has required it. And we've had sort of one-off instances in New York State, New Mexico, places like that. But the same applies to ERRC. So our firm would not stamp those drawings. But, and we can get into more of these details later, integrators who get involved and produce
Well, that's
shop
my next
drawings.
question, so you led me right into it.
Perfect.
So, Jordan and Skala, you have your own approach of how we address projects. And I understand there's options that we have. Can you kind of walk us through and let's kind of discuss what some of those options are of services or I guess levels of service we offer on projects?
Yeah, so we actually offer 3 different options for how we provide ERRC system design. Option A, as we call it, is a very kind of bare bones basic it's really code research.
Is A number one?
That's right.
Okay.
A number one. We're looking into it. We're seeing what's required in your jurisdiction. We make contact with the fire marshal. We confirm with them what they're going to require. Because the interesting thing about all of these codes is they have a stipulation that essentially the AHJ is the overriding factor. So whatever the letter of the code says, the AHJ can come in and tell you, no, we don't need that. You don't need to meet this level. You could dial it back, or we haven't seen a need for that in this city, things like that. But we make contact with them, make sure that we confirm all of that what we're reading in the code is going to apply. We document all of this in a nicely written letter. We help the architect with some of their space planning, the pre-planning for if those survivability requirements are needed. We help them plan out a general idea of what they should expect.
Okay, so that number one, or option A, you said, is kind of like the base, the bare bone option.
Right.
That's giving them the bare minimum of what they need to I guess, to make a decision. What's number two, or B?
So number two would be we actually start to provide some drawing support. So with option
So
A,
A doesn't have any drawings.
yeah, A has no drawings. There's no specifications. We're not technically designing a system. It's more of an advisory, just pure consultant
I love
role.
that advisory. That's
Yeah.
a great way to summarize it. Okay.
Yeah, we're definitely helping them, but a lot of it's being left in the architect's court to plan out shafts and things like that they may need. If they decide they really do want us to help with that and they want that future infrastructure just in case a system's needed, that's where what we call option B comes in. And this is actually our most popular product of the ERRC services we offer. And it's because worst case scenario, you're building, and I say worst case scenario from the developer's perspective. Worst case scenario, your building does need the ERRC system. You've got pathways in place. Maybe you've finished construction, you've gotten further along than you typically maybe would want to before you start installing ERRC, but you've already got conduits, you've got junction boxes, everything you need is in place to pull that cabling without expensive retrofitting, because that's usually what ends up hurting a lot of properties. They wait a little bit too late, they realize the system's needed, or they're ready to get their certificate of occupancy, and the fire marshal goes through doing a test and realizes, oh, you don't pass, you need to add a system in. Next thing you know, you're tearing up hard ceilings, you're ripping up drywall. So on top of the expense of the system itself, now you've got clients who have to go back and make repairs to the building.
Wow. Yeah, I mean, option B definitely makes a lot of sense, especially with drawings and the coordination going on.
Yeah.
That gets more into the details, it sounds like.
That's right. So it's still a basic infrastructure design. We're not really calling out any cabling or any specifics on the system hardware. A lot of that would still fall onto the integrator down the road.
Okay. So what is before we jump too far along,
Yeah.
what is an integrator? So everybody, the audience can understand.
Yeah, so the integrator is they're a third party that you bring in, and their specialty is going to be everything to do with DAS systems, whether that's the cellular or the ERRC, first responder system. So they do everything from the signal strength tests, whereas the fire marshal will come through. Their signal strength test is them carrying a radio around and basically making sure it works throughout the building. An ERRC integrator, what they're going to do is they can do that. They can do a very basic on-site test of the building, see where the radio is getting signal, where it's not. Or they can do what's called a predictive signal strength analysis, where they take information about the building that you get from the architect, with the materials, the size of the building, if it's got low E glass that, our sustainability team would help design. Every little facet like that, they plug it into their software, and they essentially create heat maps of where your signal is weakest in the building. Okay. And then they can help plan out exactly where antennas may need to be relocated. Now, it's all predictive, so technically it could change once the building is actually constructed and you have real-world data. But they can do that up front and help provide sort of a rough cost analysis, what you're possibly looking at down the road. They're a huge help to what we do. They're partners of ours. So when we're doing these infrastructure designs, a lot of our clients ask for recommendations on these integrators, because not only can they do the signal strength test, they can do the install, they can make tweaks to the final design, and they also have the certifications needed to stamp their drawings and get it approved by the AHJ.
So how does Jordan and Skala and you and your team that you run, how does that integrate with the integrator? I mean, how are you like a liaison in between? Or explain to us the relationship of Jordan and Skala and your team with the integrator.
Yeah, so there's a few integrators that we've, built relationships with over the years, who've helped us, one, further our own understanding of the systems, how we should be specifying them, what products, we should be focusing on, emerging technologies, changes that we're seeing. They've helped us with that. So what we do to help them out is when projects do come along and our clients wonder, okay, we know we need the ERRC, we've got the infrastructure in place. What's our next step? Who can install this for us? We let them know, just like with our MEP services, we're not contractors, we're not installers. However, we've got some industry partners who we know to be reliable, we know to be trustworthy and quality. We can give you a few recommendations, and depending on your geographical location, some may be more readily available than others.
That's great. I mean, it sounds like you bring a lot of value to the developer community by going that distance. So I want to wrap up. I mean, all I can tell you is you're one heck of a really cool data dude from all the information you know.
I greatly appreciate it.
And I really appreciate the time today to talk to you. I want to end with a little bonus. I think there's a white paper or something that's on our website for anybody interested in looking up more information on ERRC. Are you familiar with that?
Yeah, that's correct. So a few years ago, Fred Tanner, who used to be the head of the low voltage department at JSE, he actually wrote up an article that was very well written, very comprehensive about the history of ER, a lot of what we talked about today, the history of these systems, how they've changed over the years, how they apply to our clients. And then just a few months ago, I actually went in, made some edits to it, kind of updated a few things to meet more current changes to the codes. And my understanding is it's been a very popular read on our website. It's done very well online. A lot of people have found value in it.
And let's switch over to you mentioned option A, option B, or in my mind, 1 and 2. What is the third option when it comes to the services that you offer at Jordan and Skala to the developers and to the architects? Tell us a little bit more about option C, because there's a lot more services that are kind of bound together with different groups, right?
That's right. So option C, as we call it, is basically the full services. So this is great when you're in a high-rise building. We've had some chatter about high-rises. That's a key point. That's really where this was born out of. A high-rise situation, and those are the buildings most likely to need these systems. You're almost guaranteed if you have a high-rise building, just by the nature of, one, the height of the building, and two, the materials it's built out of. It's almost guaranteed you'll need that ERRC system.
That's because the radio signals won't go through the assembly of the building?
Right. So it's kind of funny. You always think back to when you don't have self-service. What do? You try to hold your phone high in the air thinking, let me get it higher towards the sky, I'll get better signal. But when you actually start talking about true elevation, technically that's not how radio signals work. So those antennas in the jurisdictions broadcast the signal in sort of an umbrella. So actually the higher your building gets, you do hit that threshold where the building's now high enough that you're not getting signal. The bottom of the building may, but not the top of the building. So that's true of both first responder signals and cellular service. So in a high rise, let's say you've got a 30-story hotel that you're designing. You know that you're going to need that system. So obviously the infrastructure option, why waste the money on conduit if you know you're going to need the system? Because at that point it's cheaper just to put cabling in. If you're going to need it, you may as well forego all of that infrastructure. So what we offer the client is a full design where we're actually providing specifications on all of the equipment, all of the cabling. We're still providing all of those previous levels of service, all the coordination, getting with the fire marshal to fine-tune requirements. We're still doing all of that, but now we're issuing a full drawing package that includes antenna locations, head-end equipment locations. We're showing the gear in the telecom or electrical rooms, and we're providing diagrams of all the cabling, the riser pathways, you name it.
And you're still working with the integrator on that option?
That's correct. So at that point, the integrator's an even more important partner because we're providing, it's still in essence an infrastructure, but it's a more developed infrastructure design. So at that point, what the integrator's going to do is take our design, run it through some of their heat mapping software, and they may fine tune some of our antenna locations. They have a bit more capability than us to make those adjustments. They may move something 50 feet down the corridor because maybe that part of the building's got a dead zone. They'll help make those adjustments. They can provide the client some pricing for the install, and they actually can get their drawings stamped and submitted to the AHJ for approval.
Okay. Well, you got 3 great options to consider, and it sounds like you do the second one the most, but
Yeah.
after that, you see probably the third option for those that are actually going to go
Yeah.
the path of ERRC, have the integrator involved in
Right.
full set of drawings.
Yeah, it's option C. Yeah, we still get a pretty healthy amount of that. B is the most popular, mainly because since it's just the infrastructure. If you end up putting it in and you kind of luck out and the AHJ tells you, no, your signal's good, you don't need it, you're out the cost of the conduit, which is not technically a small number, but in the bigger scope of the construction budget and compared to the pricing for ERRC systems, is significantly less money.
Well, hey, Brian, I'm so excited that you were able to join us today on the show. And it's so much fun. I mean, I've learned so much from you. And all I can think of is, man, what a really cool data dude you are. And I can't wait in the future to learn more. I mean, if you had any one thing to say about our show today, I mean, what crosses your mind?
So our clients should definitely stay in tune with Jordan Skala Engineers and make sure that they're getting the latest and greatest information on these systems because they constantly evolve. They've been evolving for the past decade plus, and they're going to continue to evolve as we have safer buildings, technology evolves, we learn more about what's going to make a more efficient ERRC system, and we can be those experts that help our clients stay on top of that.
Well, I guess when I don't see you around the office much, I figured you're going to be probably head down in a bunker somewhere, researching and studying, trying to figure out what the next trend is, because you always stay on top of things. So I don't know how you do it, but it was a real pleasure today to spend the last hour talking to you.
Of course, yeah, and thank you for having me. Glad to talk about it.
Yep.